everyone, welcome to Universal Group of Institutions. I am Lavanya. In the last video, we discussed the fourth chapter, which is acid, base and salts from the 7th grade NCERT textbook. So in this video, we'll move forward with the next chapter, which is physical and chemical changes. So if you have not watched our fourth chapter, please check out from our channel, which is Universal Group of Institutions. Every day we see changes around us, right? So something like milk turning sour, ice melting, iron rusting, and sugar dissolving in the water, settling of curd from the milk, and stretching form of the various substances, and a ripening of fruits also. But have you ever wondered why these changes occur and whether the substance remain the same or become something new? So we classify all such changes as either physical change or chemical change. So understanding this is very important or fundamental. So now first we'll understand what is physical changes. A physical change is one in which only the physical properties of a substance. What are the physical properties? Which is like shape, size, state or color change, but there is no new substances formed. Yes, a physical change alters substance appearance or state without changing its chemical composition, and there is no new substance formed. So this property or this change is usually reversible. Okay, it is usually reversible and it is a temporary process. Okay, so for example, paper cut into pieces. So if we are cutting a paper into pieces, there is a change in its form, but the chemical composition remains same. So there is no new substance forming and the chemical composition also remain intact. And the second, if we talk about ice melting into water and refreezing it into ice. So it is also a reversible process. So ice is melted into water and now if we refreeze the water, we will get the ice back. So that where substance can return to its original form. And then dissolving salt or sugar in the water. So here what is happening? There is no new chemical is being formed, but only a mixture is prepared. So the minimal energy is required in this process where little heat or energy is absorbed or it is released. So a physical change involves intermolecular rearrangements, not breaking or forming of chemical bonds. So hence the chemical identity of the substance remain the same. So here what is happening? Physical change, that means only this appearance and state is being changed. There is no alteration happening in their chemical composition. So in environmental science and geography, this concept is used to explain physical weathering of rocks, where rocks break down due to temperature or water, but their chemical composition remains unchanged. Okay, this is an important point to remember. Next, we'll talk about few of the examples of physical changes. If we are talking about cutting a page or a wood or something, where shape and size are being changed, but there is no chemical composition is being changed. Then pouring. If we are pouring water into any of the containers, what happens? The distribution of atoms takes place, but there is no changes or alteration in chemical composition. That means the chemical composition remains the same. And then if we talk about gases, where expansion or contraction of the particles with high kinetic energy is being observed. Next we will understand what is chemical changes. Yes, a chemical change or a chemical reaction is a process where new substance with new properties are formed. So these changes are generally irreversible. So what is happening in chemical changes? Chemical changes or reaction form a new substance with different chemical properties. These changes are generally irreversible. If we talk about physical properties or physical changes, it had a reversible content. If we look into physical changes, where it can bring back its original form, where the process was reversible. But at the same time, if we look into the chemical changes, the chemical changes is a irreversible process. Okay. So for example, the common example we can give is the rusting of iron, where iron reacts to form the rust. So rust is now a new substance or a new chemical composition which is formed over here. So for example, if we talk about baking soda and vinegar, which produces carbon dioxide and which turns lime water milky. Okay, so during baking a cake, what happens? A new substance is formed as heat changes the flour and sugar, right? So even if we talk about the softening of milk, when the bacteria takes an action or they metabolize, they creates lactic acid in it. And if we talk about burning magnesium oxide, where magnesium plus oxygen forms a new product which is known as magnesium oxide, that is ash. Okay, and then if we talk about the copper sulfate and iron, blue solution which changes to green, that is known as iron sulfate, with a brown deposit which is known as copper. So a new product is formed. And if we also talk about the burning of woods, so if we burn the woods, we get production of ash and carbon dioxide and water vapor also. So chemical change is a process or a reaction where a new substance is being formed, and we cannot reverse the reaction. So since we cannot reverse the reaction, we cannot get back the original form of the substance. So how do we indicate the chemical change? The common indicators of chemical changes are formation of a new substance. One thing, formation of a new substance which is irreversible and which cannot go back to its original form. So one thing is the production or the formation of a new substance. Second, change in color or odor. So this can also be said as the sensory changes. So the production of a pungent smell or a pungent smelling odor and changes of the color of a substance or the chemical. And we can also find a sound production also comes under the sensory changes. And then evolution of gas and release or absorption of energy, which is also known as energy exchange, where heat, light or other radiation may be released or may be absorbed during the process. And then formation of precipitation, which comes under the visual transformation, where a solid from a solution is formed or a precipitation is formed from the solution. A white color or a colored precipitation or a powder kind of structure can be produced from the solution or from the gases during the experiment, or a distinct change in color or of the formation of a gas can be seen, which is also known as evolution of gas, can also be seen during the reaction. So these are the common indicators of the chemical changes. So if we understand the chemical changes, the characteristics of chemical changes are a new substance is formed, one thing. Second, heat, light or sound is produced, gas is evolved, color or smell will be changed or change will take place, and it is an irreversible process. So the chemical changes involve breaking and forming of bonds between the atoms, resulting in substance with new chemical identities. Right. So in the physical changes, what happened? In physical changes which involved intermolecular rearrangement, but there was no breaking or forming of a new chemical bond. But in chemical change, what it is happening? It is involving the breaking and forming of a bond between atoms, resulting in substance with new chemical identities. Okay. Next we will move into the rusting, a chemical process. So rusting is a process where both oxygen and moisture plays a major role in rusting of an iron. So what happens? Rusting is a chemical reaction where iron combines with oxygen and water to form the rust, which is also known as iron oxide. So the moist air and water accelerates this process. So rusting weaks iron and causes huge damage to the iron particles. So how do we prevent rusting? So one thing, we can use painting or greasing. So apply paint or lubricant to shield the iron. Second, galvanization. So what do you mean by galvanization? By coating iron with zinc, especially coating iron with the zinc. And then next one is alloy formation, where mixing the metals with iron, like stainless steel, which is iron plus carbon plus chromium plus nickel, where iron coat with protective metals like chromium or zinc. This can also be used. So corrosion is a natural process. So prevention of corrosion is an industrial necessity. So what do you mean by rusting? Rusting is a chemical reaction where iron combines or react with the oxygen and water, giving rise to a new product which is known as rust or iron oxide. Next, we'll move into the next concept, which is crystallization. Crystallization. Yes, crystallization is the process of obtaining pure crystals of a substance from its solution. So, we are obtaining a chemical substance or a pure crystals from the original solutions. So, crystallization is a physical change used to obtain large pure crystals from an impure solution, such as purifying copper sulfate. So how do we do this method? First, we collect the impure solution. We collect impure solution of copper sulfate, and then a concentrated solution is being prepared, or an saturated copper sulfate solution in water should be prepared. And the third step is cooling process, where we allow it to cool down, allowing a formation of the crystal. And then fourth one is pure crystal is formed, filtered and separated from the impurities. Crystals of copper sulfate can be prepared by dissolving impure copper sulfate in hot water, filtering and allowing it to cool. First, the impure sample solution is collected and a saturated copper sulfate solution in hot water is prepared. Later, it is filtered and it is allowed to cool down without any disturbance, and the crystal forms are found in the bottom, and later it is filtered to get a proper and pure form of copper sulfate crystals. This purification method is used in chemical industries and pharmaceutical for purification. So this also connects to salt production and mineral formation in geography. Now let's connect all these physical and chemical changes with our real life applications. So in physical change, melting glaciers and the evaporation; chemical change, which is combustion of fuels; rusting, corrosion of bridges or ships; crystallization, salt and sugar refining; ozone formation or depletion, which is a chemical change in the stratosphere; and photosynthesis, which is a chemical change producing food. So next time you see melting of ice or burn a candle, observe what's happening. The melting wax is a physical change, but the burning wick is a chemical change. So this is all about physical change and the chemical change. If you find this video informative, don't forget to like, comment, share and subscribe. Thank you.